Okay, fuel control. The ideal air-fuel ratio, 14.7 to 1, also referred to as stoichiometric air-fuel ratio. It can be a little bit higher than 14.7 to 1. Sometimes hot rods, race cars, they want to go like 14 to 1, sometimes even 13 to 1. Keep in mind, this is for gasoline. Alcohol, E85, it's going to be a whole lot higher. Alcohol sometimes will run up close to 8 or 9 to 1. So the 14.7 to 1 air-fuel ratio is for gasoline. The way that we monitor the air-fuel ratio for years was oxygen sensor. Oxygen sensors mounted inside the exhaust, and 14.7 to 1 air-fuel ratio is equivalent to about 450 millivolts. So anything above 450 millivolts was considered as running rich. Anything below 450 millivolts was running lean. For years, we were taught to look at the O2 reading to determine whether a vehicle is running rich or lean. Then after OBD2, they came out with a new sensor, air-fuel ratio sensor. Sometimes this is called a lean burn sensor or a wideband O2 sensor. There's several different names that it is referred to as. The reason it has so many different names is because it came out after OBD2. Most of the sensors that were in existence when OBD2 came out, the name was standardized and used across the board. If the sensor came out after OBD2, which was after 1996, then it's not standardized. Every manufacturer out there can call it something different if they want to. But typically, the ideal air-fuel ratios or stoichiometric for an O2 for air-fuel ratio sensor is going to be 1 lambda. So 14.7 is equal to 450 millivolts on an O2 sensor, or 1 lambda on an air-fuel ratio sensor. Now, once again, since this came out after OBD2, it was not standardized. So, being that it wasn't standardized, they do not have to stick to that lambda value. Toyota and Lexus, they give the reading, even though it is still an air-fuel ratio sensor, they're giving you a reading of voltage. And 3.3 volts is equivalent to 14.7 to 1, or 450 millivolts, or 1 lambda. So Toyota, Mitsubishi, Fiat, and every manufacturer out there can call it something different if they would like. They can also give you different voltage readings. In fact, some of them know that we are used to seeing the 450 millivolts as being equal to 14.7 to 1. They're converting their air-fuel ratio sensor value over to read 450 millivolts is equivalent. So this kind of gets confusing that you've got to try to remember all this stuff. Good news though, there is something that they did do with OBD2 that makes life much simpler. That is, every manufacturer out there has to give you short-term fuel trim and long-term fuel trim. Now, short-term fuel trim and long-term fuel trim been around for a long time. General Motors and I think Chrysler used it all the way back into the 80s when they first started putting computers on vehicles, but they called it block, learn, and integrator. So with OBD2, they just changed the name of it, and now it's short-term and long-term fuel trim. Back when it was block, learn, and integrator through General Motors, the 14.7 to 1 was equal to about 128, was equivalent to the 0 of short-term fuel trim or long-term fuel trim. So That being said, we can look at short-term, long-term fuel trim and don't ever have to pay any attention to oxygen sensor readings, air-fuel ratio sensor readings, no matter what kind of value they give us. We can use fuel trim. Fuel trim is extremely simple, and 0 is equivalent to 14.7 to 1. If you see a number higher, a positive number, that means the computer is adding fuel. If you see a lower number, a negative number, that means the computer is taking away fuel. It adds fuel by increasing injector pulse width, takes away fuel by shortening injector pulse width. Long-term fuel trim is where your codes come from. If the computer sees that long-term fuel trim has exceeded 20 to 25, you're going to get a lean code set. If the computer sees that long-term fuel trim is negative 20 to 25, you're going to get a rich code set. So if you see a code that vehicle is running rich or vehicle is running lean, long-term fuel trim is the reason it is there. So something is causing this vehicle to run rich, therefore it's driving the long-term fuel trim down. Short-term fuel trim is like a fine-tune adjustment. If a car is running a little bit rich, then the first thing that's going to happen, short-term fuel trim is going to go negative slightly. If it's still running rich, it's going to increase the short-term fuel trim. And when I say increase, I mean go negative more to try to take away some of the fuel. Once short-term fuel trim cannot make this vehicle run lean, then long-term fuel trim is going to step in and it's going to go negative. So short-term fuel trim is a fine-tune adjustment. Long-term fuel trim is what sets your codes. The readings, both of them read the same way. If you see a positive number, the computer is adding fuel. If you see a negative number, the computer is taking away fuel. Look at some of the conditions. If you've got a positive fuel trim on short-term, on long-term, keep in mind that this short-term fuel trim probably is not going to reach the positive 25 unless long-term fuel trim has reached positive 25. Because once short-term fuel trim gets up to positive 15, positive 20, it's already increased long-term fuel trim to try to help it out. So things that can cause fuel trim values to be positive, low fuel pressure. Whether that low fuel pressure is coming from a restriction in a fuel filter, not enough power going to the fuel pump, high resistance on the ground side of the fuel pump, a vacuum leak. All of these things can cause fuel trim to go positive. On the other side, causing a vehicle to have a negative fuel trim, meaning that the computer is trying to shorten the injector pulse width, leaking fuel injector, leaking raw fuel into the combustion chamber, oil contaminated with fuel. I'm using oil contaminated with fuel because that's one of the examples Toyota uses. In reality, I did see this same question on the ASE test. In reality, it's almost impossible to get the oil contaminated with fuel on a fuel-injected vehicle. In the old days, when we had carburetors and we had a diaphragm fuel pump that was mounted on the side of the block, it was extremely common for the diaphragm inside the pump to rupture, and then all the fuel would leak down into our crankcase. But with fuel injection, our fuel pump is mounted inside the tank. So they use this as a question for ASE. Some of the manufacturers use it as a test question. But if we get oil contaminated with fuel, we are going to have a negative number on fuel trim, because theoretically, the fuel that's inside the oil, once the oil got up to operating temperature, the fuel would vaporize and get sucked into the intake through the PCV system, therefore burning it in the intake. The other thing that really can happen, fuel pressure regulators. Fuel pressure regulator diaphragm bust, and that little hose going up to your intake manifold is sucking raw fuel into the intake. This was real common on Chevrolet, where they had their Vortec engine and the fuel pressure regulator was inside the intake manifold. The diaphragm would bust and you would get raw fuel, and so your fuel trim at idle would be extremely negative, because they had the injectors shut down just about completely to try to compensate for all the fuel that was entering into the intake. Once you got up to operating speeds or under a load, the fuel trim on those would actually head back towards zero. Okay, so fuel trim, fuel control nowadays is really pretty simple. As long as we understand what long-term fuel trim and short-term fuel trim are, there's no need for us to sit there and worry about all of the goofy values that the manufacturers can dream up, whether it's voltage, whether it's lambda, or whatever else. If a car comes in and you suspect that the air fuel ratio sensor is bad or the oxygen sensor is bad, and you've got a, let's say, a high long-term fuel trim reading, meaning this vehicle is running lean, get a bottle of propane and hook the propane bottle of propane to a vacuum port and add some propane, richen it up. See if you can force it to go lean. There, on the other hand, if the vehicle comes in running rich, pull a vacuum hose. And when you pull a vacuum hose, make sure that the air fuel ratio sensor and the oxygen sensor will move, because that tells you that it's working. But as far as diagnosing a rich condition or a lean condition, just stick to the short-term fuel trim and the long-term fuel trim, and you should be okay.